Yes, it's a place to be.
Yeah. Yeah. Innovation Days.
Good morning. This is Morten from Inkish, and I must say today that I am very honored and very pleased to talk to a person that I have known about for quite some years, I would say, and a person that has made some significant changes to how we are actually able to even talk about fast-speed inkjet today. So welcome on Inkish, Kai.
Good morning, Morten. Good morning, everyone.
I mean, when you started Adphos, what was your expectation at the time? Was that to become the world leader of drying, or what was the vision at the time?
I mean, when we started 30 years ago, being a spin-off of the European Space Program, a group of high-educated engineers, rocket scientists, we were expecting to do some high-temperature, high-sophisticated testing devices and analysis for the industry. But I have to say, there are two very driving influences putting us to the direction where we are today. The one is we had a trial at Maulbelzer where we had to improve the speed on their running printing press, and there we realized that with the energy source we were using at that time, it was high intensity infrared. We were able to accelerate the printing process and the drying capabilities by a huge fraction without a minimum space. So that was one thing where we thought, oh, maybe that's also something to other applications. And the second more driving effect was, and that is related to the Hunkeler days, is there was the railway ticket printing of Kodak tickets in the German railway.
Oh, the two-color, that was the two-color things, right?
And that was, the barcode and the numbering on an offset printed ticket had to be put with a Kodak, at that time Cytex inkjet technology. Yeah. And this was thermal paper. And as you know, thermal paper, which at that time turned the color if the heat was more than 50 degrees C. On the other hand side, there was a need in order to apply a water-based black ink barcode or numbering. That was a challenge, right? To do this at 500 feet a minute. And this was in the late 90s. And that was our first inkjet-based solution, the hardest you can think about, but we were successful, and that turned our direction of working tremendously in the direction where we are today, right?
And when you remember back at the time, when we talk about these ticketing systems and things like that, and you know, I guess that all companies, when they have the company life cycles, there's like these aha moments in your life where you're like, whoa, this was actually not what I expected, but it became something that was really interesting. I mean, was that something that you remember back now, 30 years ago, that was like, wow, that was a fun moment?
I mean, yes, it was a fun moment, because why? The company was almost 6 people, right? So it was a small family. Everything was made out of the garage, and you have immediately a large contract with a performance guarantee. If it wouldn't have worked, they would have given out the shit back, right? And by doing this, yes, this was something very exciting. On the other hand side, that changed dramatically the business, and specifically, I think Kodak at that time understood that high speed, and at that time they did everything in printing, high speed, compact, low thermal stress, dynamic capabilities put us in the situation that almost every application we did together with Kodak or Cytex for black inks. They only had black inks applications, and that was for 10 years something where we were highly involved in most of the international projects.
And just think back on how much the market has changed since then, right? Because if you look at you say like monochrome black printing today, where you have even many colors, even more than 4 colors. Sometimes you have a lot of ink on the substrate, and it goes even faster. I mean, the requirements, if you look from then to today, is even more complex, right?
Yeah, I mean, what we have to say in these first 10 years, let's say in the early 2000s, right, up to 2010. On the other hand side, we had these laser technologies, which were homeopathic in the speed, right? 20 meters, 30 meters. I mean, we provided solutions for OCA, because OCA is 50 kilometers from us. We provided some solutions. They could have run with that 50, 60 meters, but nobody counted on that because they were happy with 30 meters, right? So the Kodak, with their capability of running at that time already 300 meters, gave the requirements for this fast drying. And I think there was also at that time a little bit the focus really on these high-speed dark or monocolor applications, and we followed too late the full color or more color applications. And I think that put us a little bit in a background, due to the fact that some of these first full color applications tried to do this just with infrared or with hot air, because they were not as fast as Kodak. And they thought color, because of the absorption characteristics, is something which does not fit with the photonic energy source we are using, right?
That is like one thing, but I was also thinking that when you look at the OEMs today that are making printing presses, many of them came from the toner environment where it was not as fast. Then they moved a little bit into inkjet, where it was still not very, very fast. And as Adphos was like maybe focusing on high-speed applications, maybe the even looking at Adphos was not the very right thing in the beginning, and therefore they started looking into alternatives. And if you look today, here at the Innovation Days, we have been filming from HP sites, from Ricoh sites, from Canon sites, and you see all of them are with the same issue, that they cannot go fast enough if they don't have the drying system that is capable of doing this. And as we spoke about before the camera was turned on, that on some of the high-end printers, also from HP, you have Adphos dryers built into these machines now, simply because you can provide that drying at those speeds and with that ink coverage. And the reason I'm saying this, I was just wondering, how did you go from let's say realizing the potentials back 30 years and then started moving forward? Because what comes first? Is it the dryers or is it the speed, right? Because if you're a print OEM, you want some speed, but if you can't get the drying, you will not get there. So it's the hen and the egg question, right?
I mean, I think if you do it systematic today, and this is done today, fortunately, you have to do it on the combination. So you need a holistic approach. In the past, you are totally right. Everybody was in their labs driving, and everybody was happy when they can put the drops onto a substrate. At the beginning, maybe nobody cared about what is the quality of that drops on the substrate. Nobody cared about what is the speed they would like to go afterwards. And then the marketing drives the process. You have to be finished at this and this time. And I think one thing we have to be clear: if you have a system like a convection process, where you have only heat flow and the temperature of the heat of the air, this is the simplest way in order to control a process. It is not the most efficient, it is not the most compact, it is not the most intelligent way, but it's the way you always will find a solution. At the end of the day, it's a question of how long time you need and what is the maximum temperature you can apply, right? And everything else follows these two boundary conditions.
Yeah.
But if you do this in a lab system where you apply an inkjet, just drop with whatever system, and you have to extrapolate that to a speed of 100, 150, or even 200 meters a minute. If I do something in a few seconds, that means at 2.5 meters per second, that means several meters, right?
Yeah, yeah.
And if you want to apply that, and if you mentioned the HP large scale machines, I mean, we are talking about almost up to 3 meters width, the HP 1100, and we are talking about up to 300 meters a minute. That means these are 5 meters a second. And if you need 2, 3, 4 seconds, you are several 10 meters long, which is longer than the full machine today, right?
Yeah, that's true.
And that is a spectrum which has been taking place in the earlier stage. And there was one, let's say, misunderstanding in the market, in the thinking. The color absorption is a given fact of the pigments, right? But only because there's a difference in the color absorption, that doesn't mean it can't be done. It is not as simple if you have a monochrome, and we needed also a little bit of optimization work and doing some adaptations. But we can say for more than 10 years, we are able to do any color application for cellulose materials. We can do, and I think this is not known yet, we still are today the only company which provide an inkjet-based press running at 300 meters at a flexible packaging application on a PP material which has 15 micron thickness, full color, with an overcoat with 300 meters a minute. Who else in the world is providing this today? And this system is producing hygienic products, full stop.
It's amazing. And I mean, for people that, maybe we should dig a little bit into what makes Adphos so different from all of us, because I think that, also when you talk to the OEMs, some are talking about UV that has its challenges. A lot of people are marketing water-based inkjet, where basically the let's say the challenge is to get the water away from the substrate as fast as possible with as little stress as possible on the substrate. And as you said already, you can have infrared, you can have hot air, and then you can have near infrared, right? That's what you have been focusing on. So you are not really applying a high temperature, but it's an energy boost that you have in that particular light space that gives the instant. Almost, is it instant or is it almost instant?
It's almost instant. Physically, it's not instant, but practically it is. If we talk about drying in a fraction of a second, I think we can call it instant.
Okay, good. So, and the reason I say this is just for people to understand that when you apply basically the speed and the ink coverage, that is a question about how much energy you apply to your drying system, right, or to the curing system, right? So basically, if you, let's say that now we spoke about 500 meters or 500 feet per minute, if we had 1,000 feet per minute, still your solution could just be scaled for it, right?
Yeah, I mean, you said about what is the difference. I think there are there are two major things we have to address. Number one, the Adphos technology is not an infrared system. Even
No,
so,
that's true. Yeah, even though it has its name in it, right?
we are using near infrared as an energy source, right?
Yeah.
That is an energy source, but not a heating aspect.
Yeah.
All the conventional drying technology, whether it's infrared, whether it's hot roll or hot plate, whether it's convection, whether it's induction, they all are resulting heat into the substrate, and due to the heat in the substrate, the wet coverage also starts to evaporate, depending on what liquid is in. And if you continue now the heat, or if you continue the energy, the heat in implication, the further evaporation takes place. And if you provide now a proper mass transfer, the removal of the vapor, you get in a drying process. That's what it is. But you have to heat up the mass of the material. You have to get all the evaporation power for the liquid evaporation, and you need the blower power for removing the vapor. You are talking the Adphos technologies with the high power photonic energy source, which is made out of NIR emitters, allows us a direct interaction, a photonic interactions with polar molecules, what you are treating. And fortunately, most of the liquids have polar bases. Most of the polymers have polar applications, and most of the substrates we are using, whether it's plastics or cellulose materials, have a high transparency in the emission spectrum of our energy source. And that allows us to have the direct drying process by swinging, similar to microwave, by swinging the molecules, the vapor molecules, and then to remove on this position by the integrated removal of the vapor, to have an instantaneous drying process without heating the substrate. The substrate gets
that's of course tremendously important, because I mean, especially on paper-based substrates, it doesn't make sense to buy a very expensive substrate if it's disturbed or destroyed by water or heat, right?
And the heat in the substrate is a result of the longer you need for the drying. It's a heat conduction problem. So it's a result, it's not a necessity. And if you take this into account, you immediately understand the advantage of why the Adphos drying technology is so advantageous in energy efficiency, in reduced heat, in very compact and dynamic operation capability. Now, the thing what makes it as an engineer or as a technician a little bit ambitious is to take the different characteristics of the substrate, of the ink, of the coverage, of the application, and the influences of the spectral properties, the thermal properties, the really removal of water properties. And when we talk about inkjet ink, we also have to talk about durability, to remove the humectants, right? Yeah. To get the durability without having a lot of humectants, especially for the temperature-sensitive material. And that is what Adphos is looking always in a more holistic approach, and not just saying, it's a water-based ink. We have to remove 50% water. This is the power. Even so, if you have dimensioned the energy to evaporate, you also have to take into account the removal of the vapor and the proper airflow, the proper air management system, and all that for a reliable system.
Does that also mean that in your R&D lab you also have to spent time on looking at tons of different substrates and tons of different inks and a lot of technologies and how it's implied in order to make sure that when you develop the next generations of your NIRs, that they basically comply to all the things that you just spoke about?
I mean, we have to see, we are now 30 years in the business, right? And the business started really from day one with inkjet. So especially inkjet applications, there is a huge documented database available
for these kind of things.
all the different kind of inks and substrates.
Okay.
But if you are developing a new system or a new application, you have to take into account there are developments, there are modifications. Go for the papers. The papers look totally different today than they have been 25 years ago. If you look about temperature-sensitive materials and even go down to the flexible packaging applications, it's a totally different requirement whether you are working with a PP on 25 micron or 15 micron, or whether you are making a corrugated board system with 150, 200 micron, right?
Yeah, of course.
And therefore these working range optimizations and settlements of the system have to be taken into account, and for that you need to go to the Adphos application technicum, and you have to apply always some trials and some experimental verifications. This cannot be only done by analytical.
No, I understand that.
Estimates, right?
Yeah. Kai, before we're going to talk about Innovation Days, I have one more question that I'm a little bit curious about, because I mean, I see Adphos solutions more and more places I go in the market, and I always think back on all the conversation I had with some of your people from the past, and I feel so intrigued about it. But I mean, is there still like room for improvements and future development, or is it a very static technology that is more about being refined now? Or
oh no, I think it's an endless story, and we have a large development and further improvement or R&D roadmap. I think what is always the case number one is less energy, right? Less energy is, we call that advanced dryer control. So how, I mean, if you see you are not applying always the same amount over the full width, you have structured pattern, you have full color graphics, which are dependent of each color, might be look totally different. Therefore, you can the energy optimization by a certain driving of the control of the dryer is a very important part. There are other things where you say, what is the drying needs? And I mean, we can determine that in the lab, highly academic. But the printer, the operator on the machine, we have to give them the right chance, and therefore we are more and more implementing intelligent measurement devices, which are setting the data according to the requirements. Take a moisture control. If you know you have in your exhaust a certain amount of moisture, and you put more energy in, and the moisture doesn't change, there is no need for you to get higher temperatures, right? Or to get higher power.
Yeah, that's true.
A printer can't do that, right?
No. So that is like where you have some kind of automation basically handling these kind of things. I was wondering, because sometimes you see, let's say, combination of technology where you have NIR and hot air, for example. Is that also to basically compensate a little bit for let's say, that maybe you use a little bit less energy on the NIR, and because there is some excess heat in the machine itself that can be reused to basically vaporize the last remaining parts, or why do we see machines that have combinations?
I think when we talk about the Adphos solutions, there's only a combination of our technology with hot air, because we implemented boosters in existing installations. So that makes an upgrade of the existing device using the existing installation. But on the other hand side, and I think that is also important to realize, we are doing, and that is something which is sometimes necessary. We are adapting a defined controlled airflow in the energy flux of our photonic energy sources in order to optimize the dryer capability. But this is not hot air. This is a defined airflow in order to remove the vapor specifically. This is not an energy-driven system. This is a mass flow-driven indication, and that is used in some very special applications, like if you are going for very, very temperature-sensitive materials and very, very thin, like in the flexible packaging. There, you have to make sure that the energy balance and the vapor removal can be set in an optimized stage, but independent controlled, right? And this combination is crucial for the success.
At Innovation Days, obviously you have some partners that already have Adphos installed in the machines on the show floor. But when you go there as an exhibitor, I guess it's not so, I mean, it's easy to understand what you're talking about, because everybody knows that if you have not a dried paper or substrate after print, it will be a mess. So that is, of course, the clearest evidence that Adphos technology is important. But how will you show it, and what can people expect when they come to your booth and learn about Adphos on site?
Everybody knows when we talk about NIR, that's the Adphos technology which is behind. And I think you also can immediately see on some of the machines which are not equipped with the Adphos technology, because of the wrap, because of the dry out, because of the heat you have involved in the systems, that whether it's an Adphos involved process or not. So that can be seen immediately, even you are not an expert or you are not looking at the data.
So that's the easy part when you go and see on the machines. But when you come to your booth, what will people then see? I guess you don't have too many printing machines there, right?
No. I mean, what we show is that we can outline the specifics of the working principle of the system. That is just graphs and some application examples. People see also videos from installations, describes layouts. But what is maybe the most interesting part is that we have a small demo unit in which we demonstrate inkjet-based ink on a temperature-sensitive plastic, which everybody tells you, oh, that is very difficult. And if you see this little small device sitting on a table, and the drying takes place in a fraction of 2-3 inches, right? I think you can immediately see that we are not using heat, that we are getting the dry effect without that. And I think that demonstrates seeing is believing. So you really see what the system can do.
And I was just thinking that I guess that one of the reasons why you also choose to exhibit is because you mentioned earlier that you can also retrofit Adphos systems. So basically, for those who are watching this interview here, that have, let's say, a digital inkjet water-based printer, and where they're not satisfied with current drying solutions and maybe even are looking to see if they can speed it up, then should definitely talk to you guys about that, right?
Yeah, and I think that is a non-neglectable part of our business, that non-reaching expected specifications, mostly, as a result of we can't run as fast as we want. Mostly it's not driven because of the intrinsic energy of the system. It is mostly driven because of the thermal influence getting this high energy, or because of effects which are getting to bad quality of the product, dry out, blistering, and all these aspects. And with that, we overcome in all these cases, mostly with a short pre-booster implementation in the given space, by doubling the speed, reducing the temperature from 120 to 70 degrees C, get a proper product being dynamic. These are the aspects. So higher performance, better quality, less waste.
Fantastic. Kai, it's been wonderful talking to you here on Inkish. Can't wait to meet you guys in Lucerne, and it's only in 12 days from now. Then we are hopefully, I know I was there yesterday, and Matthias Anaheim told me that the number of sign-ups is already on the same level as last year. So I think we will have a good show, and I look forward to meet you in person and see more about Adphos technologies also around your customers on site. So thank you for your time here on Inkish, and see you soon.
Yeah, and thank you for talking about these. And
it's super interesting, I think. So I can only understand that when you work with it every day, it must be fascinating to see that there's something that comes almost from out of space is now in the printing industry. That must be fun.
Yes, and see you in Lucerne, and have a nice day.
Yeah,
see you
too. You too, Kai. Bye-bye.